Okay, let's get started. And for today, we're going to go through some Python basics and show you how to get the notebooks, how to learn by yourself. And if you already know some programming languages, today's lecture probably is the easiest one ever. If you are new to programming, it's also good to know the some of the basic things we're going to use in this course. And on Friday, we're going to start talking about GMap, Google Engine, and geospatial stuff. So make sure that you practice. I have provided a lot of resources for you to practice if you want to. But in this course, you only need to know some very basic extension syntax, data types about Python, and then you should be able to basically go online, grab all kind of code snippets, and then just try it out, make your own work. So as long as you know how to get the stuff, how to run it, you are good to go. And if you go to the website, I'm going to show you where to get the all the notebooks. Here, the book website, GOG-4414, and then gshub.org. And if you go to this one, I showed you last time, right? So I put a lot of resources on the left side here: Python basics, Earth Engine, and PostGIS. Okay, so those are the three sections. For the Python basic, we only use today's lecture to cover it, but you're welcome to learn by yourself. Don't be scared by all the contents in here. We don't cover all of them, but I just put you there if you want to learn more. So especially for Google Engine, we pick up some of the sections, and then PostGIS for Python, today we cover the getting started, and you see it's pretty short in here. But if you understand the concept, you should be able to adapt and then try it out. So here, I'm going to show you different ways you can try things out. So in the last week, we did talk about how to create the conda environment, how to install the packages, right? And if you're doing coding, most likely you're going to find a lot of things online. So how to actually get the things, try the things out either locally or in the cloud. So there are different ways you can do that. And in the notebook in here, if you on this page, for example, if you go to Python Basic and then get started, and this is rendered using a Jupyter notebook, but it looks like a website. Nice thing is that you can, for example, I can change to, if you want the dark mode, you can click the button here, up right corner, to change this one to dark mode if you want to use dark mode. You can also full screen, right, if you want to read it in full screen. So there are some like basic things in here. You can try it out. You can also download this one as a notebook. So here, there's a download button. So if you just want this notebook, you can download this specific one. So if you click, it's going to show you, okay, download this one to a computer and then .ipynb. So this is how you can grab just one notebook to your computer. Later, I'll show you how to get the entire one using Git, okay? And then nextly, this button here, the GitHub icon. So this one takes you to the GitHub repository. Also, there's a suggest edit. If you find anything incorrect, you can submit a pull request. So if you click to go to the GitHub repository, and everything is under here, right? See, this is where the website is being built. Under the book folder, you will see here, if you click, and we have, for example, Python, PostGIS, the lab assignment, and GE. So everything is actually in here. If you want to grab the entire repo, it's just git clone to your computer. You should have all of them, okay? So, but if you want to try it out, you need to have create a conda environment, and you have the Python interpreter to be able to run. So all you need to do, like I said, click the green icon and then copy this one. Then just simply go to wherever you like. So for example, under my maybe downloads directory, yeah, looks like I already have. So let me delete all my stuff in here just to start clean, right? So anytime if you see something on the GitHub and you want to try it out, locally, first thing is just go to the green button. If you already have Git on your computer, you use Git clone. Otherwise, just use the download. So the Git is good if you want to follow this repo and you want to synchronize the changes because it might be updated. You don't want to download the zip file over and over again. So the best way is just to click this one and then come to whatever directory you want to save, and then just right click or open Anaconda prompt. But usually I would just right click, open the terminal, then just git clone, and then you should be able to get the entire repo to a computer. So git clone, Control V, hit enter, and you are getting the entire repository. And then next time, if I update anything, so for example, I told you that, oh, I update this one, I update this one, then what you need, just what command do you need to get the latest one? Get pull. That's it. Right now it's you need to cd into the GOG. Okay, get into the directory and then just git pull. It's going to tell you whether it's up to date or not. If it's not up to date, then you automatically download all the updates. So this is the way that you actually get all the course material from here. Then you can go to whatever directory you want. You can open, right click, open using Visual Studio Code under here for the root directory, or you can go to a specific directory. So for today, we're going to, for example, Python in here. So I get into this folder, and for each file, you want to see .md and also IPYMB. So you can either read the markdown or you can run the code using Jupyter Notebook. So for example, I want to test it out. I just right click and then open with code. So you want to open using Visual Studio Code. Then you can start running through the code. So this is the recommended way of getting examples, code snippets to your computer, and then just try it out. But again, you need to make sure that you already have the contact environment created so that we can activate it. So now if I open this one, and if you open the MD, this is just the markdown file. So the markdown, the MD and the IPYMB, they're pretty much the same content, but it's interchangeable. So I have a program that if I change the markdown, it will also automatically change the notebook. If I update the notebook, it will automatically update markdown. So you can think about these two files is that two different formats representing the same stuff. Okay, but markdown is basically easier because I read it, I can change it very quickly because it's plain text. Jupyter Notebook, it's still plain text, but it's actually a little bit more difficult to see the content. You can certainly open using Notepad, but it's not recommended because it's a little bit. There are some lot about. Let me show you. If I can show you here, I can open, for example, Notepad. If you open using Visual Studio Code, it's already rendered. But if you open using a Notepad, so for example, I'm going to drag this one, open the notebook, take a look. Right. So this is what the Jupyter Notebook looks like. A Jupyter Notebook is still a plain text file, but there's a specific format that IDE can use to render. But usually, if you look at this one, right, you can understand it, but it's just like too complicated because every markdown cell is going to have like dictionary, something like that. But if you open the markdown, oops, the corresponding markdown is much easier because it's cleaner and it's very much more concise, right? If you look at this one, you can read it and you can make changes. So basically the website is built on top of the markdown, but you also provide the corresponding notebook that you can use to run code. So if I double click the notebook, like in here, right? So take a look at this. We have, I'm not sure if you can see clearly, but here we have text. We have the code block, right? So the code block is the way you can actually run source code. You can do it. Let me see. I can zoom in a little bit. Where's the shortcut? See here. Here's zoom in. Okay, so let me. Is it better now? Yeah. So I zoom in a little bit. So like I said here, if you for all the code block, right? This is what is rendered already the output. But if you double click, you will see this. So these are also called markdown. So markdown is basically a markup language that you can use to write code, but similar to Microsoft Word document, right? You have heading 1, heading 2, you have bullet points, you have number list, something like that. So we can just use the pure markdown to write. And then when you hit Control Enter, it's going to render looks like this. So if I want to make any changes, I can just double click. I can, for example, I don't need this one, just remove it. And then Shift Enter, Control Enter, Alt Enter. So those are the different shortcuts. I think most of the time I use Alt Enter because it will automatically create a new code block and then I can start writing code. Shift Enter is like you run, you move to the next one. So if you're just trying out, if you're running on a Jupyter notebook, you just want to run through it, then it's probably okay to just use Shift Enter because it moves to the next one. Control Enter is you want to try the same code block over and over again, so it doesn't move your cursor onto the next one. So let me show you what it means, right? So right now, if I do this, first one I'm going to show you is Control Enter. So I'm going to type Control Enter, so see what's happened after it's Control Enter. See that? This is to create a new code block, and then you can start writing. For example, print hello world, whatever, right? So in here, this is where I can. Oh, if you on a markdown cell, if you press Alt Enter, it's going to create another markdown cell. But if you want to create a code block, then you need to click this button, Add Code Cell. Now this one here has the button that you can actually run the code. So you can think about markdown as like Jupyter Notebook has two components. One is just text. The second one is the code blocks. So code block is where you can execute code, and the markdown block is basically for you to write description. You can also insert figures, insert text, or something like that. We will not cover a whole lot, but I can quickly show you. For example, I can create another one. If you want to render some kind of photo, you can do that in here. And so let me show you. Maybe I can just go online, find any images. Let me see if I can find funny GIF. Okay. How about this one? Is it moving? Yeah, it's moving. So, and I'm gonna just copy this image address. Okay, and we Control V. So for example, make sure that the address, this URL is a direct link. Okay, so if it is a direct link, I can render it within the notebook. So I can just copy this one and then come back to the notebook here. So if this is a notebook, I can create a new markdown cell. And if you want to render images, it's exclamation, square brackets, and then parentheses, and then just put the URL in there. So this is how you render images within markdown. So if I run it, see that? So now my markdown can have text, it can have images, can have video. So it basically it's more like rich text. And this is why, for example, if you go to even the book in here, like I show you, right? If you go to, for example, chapter 1 here in Jupyter, you see text, you see all the heading, you see bold text, italic size, figures, all kind of stuff, and also code blocks, right? So this is a nice way. It's open source, it's free. You can use to write journal articles, you can use to write books, you can use to write tutorial. And this is essentially what I use to write books and lecture material, something like that. But I'm just showing you like what you can do, but you are not required to actually to master all of this. You are welcome to learn it when you have time. But what I want to show you is that you need to be able at least to see if you want to make some changes, you can do that as well. You can write text, you can write code, you can add images, something like that. Okay, and if you double click, it's going to hide this one, so it's not run yet. So this is how you can get the notebook. And of course, if you want to run it, you need to select the kernel. So when you open the notebook, one thing you need to select is if you want to run the code, select kernel, and then Python environment. After that, you should be able to see the list of all the Conda environment that you created in the previous lecture, right? So here I have a G environment. I just select this one, and then you should be good to go. So once you select, now I can just go to any code block. I can run it. It's going to take some time. The first time it might be slow. And once it's done, you're going to see a green check mark here and 0.0 seconds. That means it takes literally less than 1 second to execute the code. Right now, we don't show any output yet. We'll come back to this later. But this is the overall steps that if you want to download any notebook from GitHub, not just for this course, but it can be any notebook, and even to run it on a local computer. So for this notebook right now, we're not using any external libraries. This is just using the built-in Python standard library, so you don't need to import anything yet. But later on, if you try out some other packages, people develop, for example, Gmap, SciPy, whatever package you like, then you need to make sure that your Conda environment have those packages installed, right? So what you can try is go to the GitHub repo, look at the web page, and then just Conda, check out the Conda first. If this exists, you conda install or mamba install, and then -c conda first, and something like that. Install the packages, and then you can run. Okay, so this is one way you can do that. And next, I'm gonna show you the other way, how to run things in the cloud, because if you are on some Mac computer, it doesn't have the environment set up. Nowadays, you can run pretty much all kind of Python programming in the cloud without having to install anything on your computer. So if you come to, for example, let me show you like here how you run it, right? If you go to any notebook you like, okay, this looks cool, I want to try it out. Upper right corner here, there's the icon here. So this one shows you two, Binder and Google Colab. User, I would recommend go with Google Colab because it's instant. So if I click that, it's open this notebook in Google Colab. So let's try it out, right? Open, and you can pay attention to this URL. So it actually is grabbing the grab the URL at the notebook from GitHub. And now take a look. It's within Google Colab. So Google Colab is a cloud environment that allows you to run Python program, and it's free. It's not open source, but it's free. You can run a tons of stuff. It also has GPU. So if your computer doesn't have GPU, if you want to do some deep learning, some AI stuff, you can using Google Colab, and you can change to GPU. But it's not unlimited. Each account might have some quota, so after exceeded, they might not allow you to use that. But this is basically, think about, you have a computer virtually in the cloud. Right now, it's not activated yet. Upper right corner here, you see this one, the connect button is not activated yet. But what I can show you is, if you click runtime, and then click change runtime type. This is where you can change whether you want to use CPU or you want a GPU. And you can have T for GPU or TPU, whatever you want to choose. But nowadays, even new, probably CPU is fine. But if you're doing AI, machine learning, deep learning stuff, sometimes you need the the GPU. So here, you can run either Python or you can run R. So for some of you would like to use R, you can use it here. You can install all kind of packages. You can run R code pretty easily without having to run things on computer. So behind the scene, this is a Linux computer. It's like virtual computer. Okay. So when you want to run it, open this one, and then on the left side, there's also, if you click upper left corner, table content. This also help you can navigate through. So this is more like the heading. Each heading, so you can run through that. You can add changes, and the heading basically is just two hashtags. And this is when the markdown is being rendered. It becomes so if I shift enter, it execute it, and it render the content. So if this is what you want to try it out, then once you open, you can just start just clicking the one button, or you can if it is not activated yet, it's going to activate it. But you can also do this specifically explicitly. Basically, you are connecting. So you need to log into your account. So I'm going to log into my account. UT. Sorry about that. I should have logged in. And you can log into whatever Gmail account you want. So it doesn't matter. And as long as a Gmail type of account, you should be able to use that. So I'll show this again. Hope it works. And this is how they keep track of like who are using that, so that you're not being abused. Because if you do something like abusing the resources, your account will be banned. You might not be able to use this again. So, but this is the easiest one you can get started. Now you can click connect, right? You say allocating, connecting, initializing, connecting. So done. So basically now you have a computer. So look at this one. If you hover your mouse over here, it says RAM 0.75 gigabyte and 12 what's that? Basically you have almost 13 gigabyte of RAM and 107 gigabyte of hard drive storage. So it's a pretty decent one. It probably is better than your laptop computer, unless you have a much larger one. So with this, now you can start running the code. So you can just click here and run anyway. You see, it's done. It's pretty quick, right? So you can run through that. If you see the green check mark, that's good. That means it's executed, it's done. And you can run whatever code that you want, right? So this is where you can run a notebook. And like I said, right now, this one we're using like the basic Python stuff. We don't use any packages yet. So if you open any notebook, you want to try it out, and you will need to install the packages. I'll show you more examples later, but this is the second way of running code examples in the cloud, right? And because right now I have this website here, you can just click the button. But if you go to any GitHub repository, if it doesn't have, like, not all the repository has this Jupyter notebook rendered and created nicely for you. So I'm going to show you another way that how you can actually open things in on Google Colab. Okay, so if you go to the repository, right, and this is pretty much very common. You're browsing the GitHub repository and you want to try something out, right? So I can show you how you can actually open this one on Google Colab. If you go to just any folder, if the repository provides some Jupyter notebook, and this is how you can try out. So I'm going to go to maybe this Python folder and then notebook, right? So you're going to open any notebook in here, and compared to Jupyter Google Colab, this is static, okay? This one you cannot run. This is just for viewing purpose only. You cannot run the code. So now pay attention, okay? This is kind of a trick that you most likely want to use, okay? So go to the URL and then make sure that there is a direct link to an IP1 notebook. So what you can do here is github.com, and then just place your cursor after GitHub and then type to Colab. Yeah, you already know that this is great. So, okay, cool Colab, and then .com. Hit enter. You see? So basically, you can open any notebook stored on GitHub without having to like figure out the URL, what you need to do. So once you type to Colab, it's going to automatically redirect the URL and then open this one. And now you can just, again, you can open it, you can run it, you can do whatever you want. So this is the kind of easy way for you to open any notebook on Google Colab, so they can try it out. Of course, you're welcome to download this notebook to a computer. So if I'm going back to, let me see if I can go back. Yeah, so I'm going back to here. If you want to download this one to your computer, upper right corner here, there's a download button, okay? So download raw file, and then you click, then you can download this notebook, okay? But you can also download that one from the Jupyter, the book website. But I'm showing you because not all the GitHub repo have a book website for you to download. Most likely just like they put the file in here. If you want to try it out, you download it by yourself, okay? So this is one trick that you can open in Google Colab. Second one I want to show you is how you can actually open the GitHub repository using Visual Studio Code, so that you can actually use a browser. Because for this one here, if I want to see the content, I need to click, and then I need to click. You need to basically navigate. So sometimes if there are too many hierarchies, it might be difficult to figure out. And there's another trick that you can use. So I'm going to show you again. You probably can try it out. So github.com again. In this one here, I'm going to type GitHub, and then another shortcut. 1 second. Okay, github1s.com, and then whatever GitHub repository you are seeing, and just hit enter and take a look. It's going to open this one using Visual Studio Code. So in that way, it's still on the web, so you are not actually using Visual Studio Code installed on your computer. You're using the browser. And now I can open this one. It's much easier to navigate. It's much faster. Right? I can open, for example, Python, right? I can open this one, double click on the right here. It rendered nicely. But you cannot run this one yet because it's free, it's in the cloud. If you want to run it, you will still have to use Google Colab or Binder. But I'm just showing you, if you don't like what GitHub, like navigation something, you can use this. Okay, so github.com, whatever, you can either GitHub to Colab or GitHub 1 second. Then these are the two ways you can actually use that. If you forget, you can always come back to the course website, resources, and then if you scroll down, I think I put here Google Colab. You can click the link. So this is a blog post that I put it a while ago, and show you some of the shortcuts, some of the tricks you want to use if you want to use Google Colab. But like I said, it's pretty simple. Open that, and then you can like Control Enter, Shift Enter, Alt Enter, whatever, and then you can start trying things out. Questions? All right. If not, next I'm going to show you, for example, you find online something else, and you also want to try out the notebook, then you need to install the packages. So it's pretty easy. So I can, for example, go to the LeafMap website, and I can maybe try out any notebook I like, for example, number 1. And in here, so I also provide the buttons, allow you to open in any of the cloud environment, AWS, Microsoft Printed Computer, or Google Colab. So I'm going to open in Google Colab, right? So the same thing, this is take you to the notebook. And different from the previous one that we use is, if you're trying to run the code, for example, I'm trying to run LeafMap. So if you run it, most likely it will tell you that the package is not available. You see here, no module named LeafMap. So think about Python is a programming language that it has the core functionality, it's called built-in, and also have a lot of extra functionality that people develop. And if you want to use something else other people develop, you need to install it, and then you can import it. Right now, you're trying to import, but you haven't installed yet, you cannot use it. Kind of like you're trying to get into this building, you want to use this computer, you need to get into this room first. You need to know where that room is located, and then you can get into there, you can have access. So there's kind of hierarchy you go through. And if you're on Jupyter Google Colab, you can use exclamation pip install something. You cannot use Conda or Mamba on Google Colab, okay? Only pip install. And like I said, under the hood is a Linux computer. So you can use pip to install many packages, but not every package will work. It's based, sometimes they need C compiler, they need some complicated stuff, it won't work. But for most packages, I can just pip install. So if you want, for example, here, you can just Control / remove the hashtag. So the hashtag is basically a command. It's not going to run. And then you just exclamation pip install, then the name of the package, then just click run. It will go ahead to download all the package and run and install it. So this is usually the first step you need to do if you're using any external packages. And once you install, then you can use it, right? You see, it's done. Sometimes if at the bottom here, it shows you some error asking you to restart the kernel, then you click the button to restart the kernel. Or you can go to the runtime, and then you can say restart runtime, okay? If there's no error, it's fine, but it's to be safe, usually you want to restart the runtime. And there's also a button here, you can clear the output. So if there's like too overwhelming, I clear it out, so it doesn't show up anymore. After installation, now I can just click import LeafMap, you see? So this time, there's no error anymore. That means the package right now is available on Google Colab. And you can run this one again, run the new code block, you see? So now I can create a map. So easily, this is how you run packages. And we're going to use the Gmap starting from Friday, but for now, this is another package, LeafMap, so it doesn't use Google's engine, so you can just run whatever you want. I can click here. I can, for example, I can change the base map. Okay. So there are a lot of interactive GUIs that allows you to load the data, create a map, and it's only, most of those only one line of code. And of course, if you are trying to run this notebook on a local computer, you also need to conda install, okay, LeafMap, Gmail, whatever external packages. Okay, so this is how you find any notebook you like. If you want to try it out, you can download it to a computer. You can git clone. You can open in Google Colab directly. And there's another one here called Binder. Okay, so Binder is another cloud environment. It's free, but it's a little bit slower than Google Colab. The downside of using Google Colab is that everything is temporary. Okay, so if you install a package now, if you close the notebook, everything is gone. So this is more like temporary space. It doesn't install this one to your account. Okay, it's just like a virtual computer. Once you're finished, once you close the browser, it's destroyed. So don't save any sensitive information or critical information under here. If you want, you can always copy the notebook, save this one to your computer. So file, and then for example, save a copy in Drive. Then it's going to save a copy. Otherwise, it's just for you to try things out. It's not saving things to your computer. So pay attention. So next time, if you open the notebook again, you need to reinstall everything. So this might be a little bit time consuming, but installing some packages that takes a while. But Binder is something that's kind of a install the packages, so you don't need to reinstall it. But it's going to base on some of the dependencies that you provided. It's a bit more complicated, but at least you know how to use Google Colab. That's good enough. And if you don't want to use Colab, then try out on your local computer. On your computer, if a package has been installed, it's done. It's always there, so you don't need to reinstall. So that's usually I would recommend that you try it out on your computer. Okay, any questions? I provide both. So actually, so for Binder, let me show you in here, right? I can open here, Binder. There's a link in here, show you to the Binder. So if I click the link, so you can think about Binder is also free, but unlike Google Colab, it's instant. So you see here, is like you need to build the computer for you. So if this like you have a lot of dependencies, it's going to take a while. And the upside is that once it's built, I'm seeing the image, the computer is stay there, I think for, it's not up and running, but there's a so-called Docker image that's saved. And I don't know how long they delete it, but next time when I open it, it's instant. And the package is already installed. So the package actually come from here. So let me show you the dependency. So if you go to the GitHub repository, so if you create any GitHub repository, and then you put a requirements.txt in here, you can put any pre-existing packages you want to use, for example, Gmail, whatever. And then, so when it's building the computer, you can read this file and then you can install the package for you. So if you send the link to someone else, when they open it, they can run the code directly. They don't have to install. So this is the upside. The downside is that the hardware is not as good as Google Colab, and it also is not instant. But the other downside is they have some limit on the concurrent connections. So if you are teaching a large class like 100 people and then trying to open the same notebook, most likely it will fail. Google Colab is more scalable. So you can have tens of thousands of people like working on this, open the same notebook. It will work just fine because it's separated. So, but if Google Colab doesn't work for you, or you already exceed the limit, then you can try Binder. Binder is always free, but it's not as good. Colab. So both of them are upside and downside. It's up to you to use. And Google Colab, Binder, they're also having issues trying to get the resources. So think about these are all using the cloud, and this resources that they provide is for free. Is donated by those tech companies, and they're having issues trying to maintain the capacity because all of a sudden some of the companies stop donating those resources. Then I'm out of money. So basically, it's like doing some volunteer work, right? I'm helping, I'm organizing, and then, give me some money, and then I provide some food for you guys to eat. Eventually, you go stop donating, and then okay, I'm going to stop providing. I don't have money to actually out of pocket to provide. But Google Colab is different. Google Colab, they have money actually to continue to support, and it's very popular. So definitely, I think you want to use it from time to time. Okay, so those are the different ways. I show you a couple ways that you can get the resources, try things out locally or in the cloud. And now you know how to run things. You can learn by yourself now. Okay. ChatGPT is the best teacher for you. So all the Python basic stuff, just copy any code, put into ChatGPT, asking, explain what it is. Okay. So in the future, if you have any questions, ask ChatGPT. If it doesn't help, ask your classmate, ask the send email to Lisa, and then the last one is me. I'm okay, always here to help you out. But if I show you here, for example, come back to here. I'm open this notebook, okay? And so the first one here, get started with um, Python. And right now, I can tell you, I asked ChatGPT to give me this notebook. I don't create this notebook by myself. I asked ChatGPT, give me some Python code examples for Python basic. And you give me this text description, source code, and then just copy and paste put in this one. I don't need to write. Of course, I need to like do some formatting and stuff, but it's very, very powerful. And the other notebook is actually from the book. So here for this, a little more description, but you're welcome to read it. Like I said, you can go to the course website, and then from here, we're not going to cover all of them, but today we quickly show you some of the basics. And all the text here have text, have description. You can try it out. If there anything you don't understand, if the text here is not enough to explain the concept, then you ask ChatGPT. It should be able to help you out. Okay, these are very common. So anything that's very common on the internet, ChatGPT knows a lot. Okay, definitely it knows a lot more than I know, and you try to utilize that to learn. So here, I will quickly go through some of these key things that you need to understand, the basics. So in Python, you can think about it's object-oriented language. Object-oriented means uh, everything somehow has a handle in the memory, and then you're basically accessing whatever the object has. Think about each of you in here, right? How do I know you, right? How do I get access to information? You need to have some kind of your name, or either your NAC ID, whatever your social security number, right? And then I can access you, right? Once I know the name, for example, pointing to you, I know your height, I know your weight, I know your address, something like that. So object-oriented language that you assign something to a identifier, and then with that identifier, you can do all kinds of things. You can get the information, you can do something. So that's kind of the nutshell about object-oriented language. So here, in Python, we have different variables. So you can have a string type is single quote or double quote. Okay, either one is fine. Just be consistent, and then you assign this one to a variable name. So pretty much all the programming languages execute from the right to the left. Okay, when you read this line, name equal to John. Okay, so when Python is executing, it's not like name equal to John. It's actually from the right creating this string, and then equal sign is basically, so equal sign means assignment, assigned to this variable name. So we have the string first, and then create a variable. So it's always reading from the right to the left. Okay. So also you have a number, for example, integer, floating point, and also Boolean. So Boolean is true or false. We talk about some of the conditional statement, but this is actually what Python is. So if I run it, why it doesn't show anything? What's going on? Is it supposed to print out something? No, it's just assignment, giving something to something. When you want to see the content within those, you need to ask for it. So in Python, in Jupyter Notebook, you can just simply type the name. For example, I just type the name of the variable, so name, and then Alt Enter. You see, so now you see the content. If you're in a Python script, right now we're using Jupyter Notebook. So by default, if you type the name, is the variable name, it's going to print out the content. But if you're using a Python script, you need to explicitly call the print function. So the print function print out the content. And you see here this the same, except that it has a single quote or double quote. And you can do the same thing. For example, I can maybe age. right? You see the number. So when you do the assignment, you will not do anything. Also, make sure the variable needs to exist. If I just type, for example, SSN, it's going to show here, okay, the name is not defined, right? So why? Because everything here needs to be already created in the memory. It doesn't exist, you cannot, right? So in this in class here, right, each of you, I know your name. If I try to find something, for example, Elon Musk, not in this class, you're not going to be able to find it. So this is like the variable name, but you can assign it, for example, 1, 2, 3, 4, 5, 1, blah, 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 right? And then can enter. And with this, now I can run the number. So in Python, basically everything is like an object. And then with that object, you can do a lot of things to that object. So similar here, for example, name. Let me quickly show you here. Name, right? It's an object. For any object, you can just press dot, and then automatically in Jupyter Notebook, it's going to show you here all the functions associated with that object. So either it's a string, it's a number, it's a floating type, you're going to have this, right? So here, you see dot upper, right? You better just press tab and then parentheses. So all the methods, all the functions, you need to most likely need to have a parentheses. If they're not, it is just attribute. Okay, attribute means here. Think about here. You have a name, your color, your height, your address. Those are so-called attribute or property. If you're taking some actions, that's called a method. Right? You can run, you can read, you can swim, you can walk. Right? So those are associated with some actions. So most object either is have some properties, or you have some methods. Method means like do something, okay, get some result, do whatever. So in here, right, name dot upper. Now it's going to convert to uppercase, or I can name dot title case, right, parentheses, convert to title case, right? Or I can also do length is the function to figure out how many characters it has. So Python has a lot of functions that you can call. So think about it's just like a building block, allow you to do something. Okay. So try to run some of these notebooks. Again, we don't have time to go through all of them, but it's basically defining the variable and then accessing the values and then do something based on the values. And next, some basic operations here, right? Some basic mathematical equation, plus, minus, multiply, divide, and also the modular. So modular is basically just to get the the remainder of this object. So, and also keep in mind, if you have the same variable, you use it and then you have assigned to something, it's going to override the previous result. Okay, so right now, if I just type result in here, what do you think the outcome will be? What? 1, right? Because you have this result, you didn't ask for it. Next time you override, so you're going to keep overwriting that until the last one. So 10 divided by 3, you're going to get 3, and the remainder will be 1. And that's why you see the 1 here. You also have the, for example, the comparison. So this is important. Like I told you here, this might look very confusing. But as I mentioned earlier, Python execute from the right to the left. Okay? So what this one is doing here is actually, okay, is 5 equal to 10? Yes or no? No. That's going to be false. And false assigned to this one is equal. So is it equal? No. It's going to be false. Right? So it's either true or false. Right now, how about this? If I change to 10 and run this one, is it equal? Yes. So you can do the same thing. And 5 not equal to 10, true or false? True. Then this not equal is true. Right? Do the same thing. So 10 equal or greater than 5. Basically 5 less than 10. Okay. But this is the condition, and the result of the condition assigned to a variable. So make sure that you understand how Python is executing that. Of course, like if you don't understand, just copy abstract.bt, explain what this is doing, what Python is doing in this line. It will give you very detailed instruction. So similarly here, this is also so-called logical operation. Is you have two conditions, true and false. If you want to, if and, that means all the conditions need to be met. If there's or, that means you only need to make one. Okay. So for example, if you are trying to apply for scholarships, financial support from UT, so there's a different condition. So number one, your GPA need to be above 3.0, and your household income need to be beneath 50K, for example. So if these are the conditions, if this and then you need to meet both. If you have GPA 3.6 and then your household income is like 1 million, you're not going to get the scholarship, right? But or means you only need one. Either your household income is below 50K or your GPA is above 3.5. I don't care how poor you are, you can get a scholarship, right? So this is and means true and false. Is this one true or false? Right, true and false. What's the result? It's going to be false, because if you have an and, you need to be true in order to be true. If you have one false, then it's false. But or means you only need to have one true, then it's true. Okay. So similarly, it's executing from the right to the left. Okay. There sometimes might be one condition is not, it's never really executed. I will show you more examples later in the future. And the not means it's the opposite. Okay. If this true is false, it's not false, then the result will be true. Okay. So those are some of the basic. And then control flow is so-called sometimes so-called conditional statement, is to give you something and then you to figure out based on the condition you want to do something. So it's if, else. So these are optional. So you can just have a standalone just like this, if something and then you do something, right? So if your GPA, if your final letter grade, the cumulative grade is above 94, it is an A. If it is 90 to 94, it's a minus, right? So those are the things that you can write condition. And also in Python, there's a so-called code blocks. For condition, you need to have a colon at the end, and you need to indent. So Python is very sensitive to indentation. If you don't indent, it's not going to work. So here, right, if I remove this one, and if pi is x equal to greater than 0, and then print out, you see the red line here, that means your code is not formatted properly. And nowadays, most of the IDE can help you identify those errors. So you just hit tab. Okay, don't use the space. In Python programming, when you like indentation, don't you like 1, 2, 3, 4. You can do that, but it's not recommended. So it's always a tab 1 tab, and then you're done. Then I execute it. Okay. So right now, for example, x equal to 10, is it greater than 0? Yes or no? Yes. So you're going to execute this one, and you're going to skip all of others. So only one condition will be executed. So right now, for example, x equal to negative 10. What will be the outcome? So you're going to run this one. It doesn't work, and you're not going to run this one. So you're going to check the next condition. X less than 0. Yes. And then print out this one. All right. So pretty simple. So those are the if and conditional statements. You can also have this. So this is by a square bracket. So you have all the items in the list, and the item does not necessarily need to be the same type. Here, although it's all string, but I can add any type. Okay, so I can, for example, comma 1, comma 2, and then comma 2. It works as well. Okay, so it doesn't matter what it is. A list is basically a combination of things, and it can be any type. It can be even an object, and then you can just do the looping. We're gonna do when we do the Google Sending and Gmail, we're gonna do a lot of looping. So looping is the essence of programming, is to help you automate it doing boring stuff, so you don't have to manually to do that. It's just so easy. So for example, right now, okay, yeah, I have all the names of you. I just want to get your first name. I just run the loop, get it very quickly. We will try out more examples later in this course. But also you can have a while loop. A while loop means is that you don't know the stop condition. You know the stop condition, but you don't know how many times you need to do the looping, right? So it doesn't care how many. As long as you meet the condition, then you stop. Okay. So in here, count equal to 0, and then count less than 5. Yes, print it out, and then count becomes 1, and then go back again. Less than 1, less than 5. Yes, then print out until it's okay. 5 less than 5. No. And stop, execute. So again, copy this one to ChatGPT. You'll be able to figure it out. And we are running out of time, but there are only a couple more in here. We maybe next Friday we quickly go through all those, and then we get into Google Science. So make sure that you spend some time if you're new to Python programming. Try out some of those notebooks. You don't have to understand or go through everything, but highly recommend that you try it out, and then let me know if you have any questions. So practice. We might start having quizzes next week. Okay, so make sure that you understand. Of course, ChatGPT can help you, but it's better that you understand before you ask ChatGPT. Okay, that's all for today, and I'll see you on Friday.